And now in this lecture we find out the area of the green shape using two different methods. In the drawing, we have rectangle ABCD. This is side AB of a rectangle ABCD. It equals to 3 units in Israel. This is line segment AE. It equals to 1 unit. And this is angle BEC. This equals to 45 degrees in its size. Again, our task is to find out the area of this green shape. The green shape is actually triangle BEC. So we have to find out the area of this green triangle BEC. So first of all, we know that all the angles inside the rectangle are right angles. So those 4 angles, they are all right angles. In the next step, we will define line segment ED, this line segment as X. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABCD, side AB equals to the opposite side DE. But AB is 3, therefore the opposite side DC. Again, side AB equals to side DC, the opposite side DC. But side AB equals to 3, therefore the opposite side DC must be also equal to 3 units in its length. Likewise, according to the sum rule, in the same rectangle ABCD, side AD must be equal to the opposite side BC. But AD in total equals to 1 plus X, and therefore the opposite side BC must be also equal to 1 plus X units in its length. So, triangle ABE, this is triangle ABE, it is the right triangle, so we will implement the Pythagoras theorem on this right triangle, triangle AB. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, in the right triangle AB, here by PT is evaluation of Pythagoras theorem. So in this right side AEB, according to the Pythagoras theorem, BE squared, that is the square of the hypotenuse, equals to AE squared plus AB squared. And again, in this right triangle ABE, according to the Pythagoras theorem, BE squared, that is the square of the hypotenuse, equals to AE squared plus AB squared. BE is the missing tangent, so we leave it as it is, so it is BE squared equals to AE squared. AE is 1, therefore A squared is 1 squared, that is 1, plus AB squared. AB is 3, therefore AB squared is 3 squared, that is 9. So in total, we should find out that BE squared equals to 1 plus 9, that is 10. BE squared equals to 10. Here we will take out of this equation and finally get that the missing hypotenuse BE is equal to the square root of 10 units in its length. And again, we found out that this is the missing hypotenuse BE, with the right triangle AB, that is equals to the square root of 10 units in its nerve. So right now, B equals to the square root of 10 units in its nerve. In the next step, we will implement the Pythagoras theorem on this right triangle, triangle EDC. Again, we will implement the Pythagoras theorem on this right triangle, triangle EDC. Here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, this right triangle EDC, EC squared, that is the square of the hypotenuse, equals to ED squared plus DC squared. And again, in this right triangle EDC, according to the Pythagoras theorem, EC squared, that is the square of the hypotenuse, equals to ED squared equals to ED squared plus DC squared. EC is the missing hypotenuse, so we leave it as it is, so EC squared equals to ED squared. ED is x, therefore ED squared is x squared plus DC squared. DC is 3, therefore DC squared is 3 squared, that is 9. So in total, we found out that EC squared equals to x squared plus 9. Here we'll take out all those equations and find again that the missing hypotenuse EC of the right triangle EDC is equal to the square root of x squared plus 9. So this is the missing hypotenuse EC that is equal to the square root of x squared plus 9. In the next step, from point E, we will draw perpendicular on BC again. From point E, we will draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to our construction. We define the tangent point of the perpendicular from point E, and side BC, this point is point S. So line segment ES is perpendicular to BC, and therefore we can relate to line segment ES is the height to the base BC. Again, line segment ES is the height to the base BC or triangle BCE. Therefore, we define line segment ES as edge. It is a relation for height. That is to say, line segment ES equals to edge units in itself according to our definition. So this is quadrilateral ESCD. In quadrilateral, no, this is quadrilateral ABSC. In quadrilateral ABSC, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 pieces angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that said that the sum of the angles in quadrilateral is equal to 360 degrees, and therefore this 4 pieces angle must be equal to 9 degrees in its size. So in quadrilateral ABSC we have 4 right angles, therefore we can relate to this quadrilateral ABSC, so after because it has 4 right angles. This is the small quadrilateral ABSC, that is a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So in the small rectangle ABSC, side AB must be equal to the opposite side ES. But AB is 3, therefore the opposite side ES must be also equal to 3 in its length. So ES equals to 8 and therefore AG equals to 3. That is to say that the height to the base BC edge equals to 3 in its length. While the length of the base BC, in total it is 1 plus x. Okay, so therefore we can actually calculate the area of the right triangle BCE according to the rule that says that the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of this green right triangle BCE, that is the area that you are looking for this question, must be equal to the base BC times the height to the base SE over 2. So write it down. That is actually the area of the green shape. So the area of the green right triangle BSE and the area of the right triangle BCE, that is right triangle BCE, equals to the base BC times the height to the base, that is edge, over 2. And again, the area of this right triangle BC, that is actually the area of the green shape, that is the area that we are looking for this question. Total equals to the base BC times the height to the base, that is edge, over 2. The base BC equals to 1 plus x units in its length. And the height edge equals to 3 divided by 2. So in total, we found out that the area of the green shape, that is actually the area of the green right triangle BCE, is equal to 1 plus x times 3 over 2. So it is known. So according to equation 1, the area of the green shape, that is actually the area of the green right triangle BCE, is equal to 1 plus x times 3 over 2. This is according to equation 1. You can calculate the area of this triangle BC in a different way. Actually, the area of any triangle equals to the multiplication of the two sides by each other times sinus the angle between the two sides over 2. And therefore, according to the formula that I presented to you, the area of this triangle, green triangle BC, equals to side EB the length of side EB times the length of this side CE times sinus the angle between those two sides, that is 45 degrees, that is to say sinus 45 degrees over 2. And again, according to the second method, they have this calculation, they have this green triangle BCE equals to the multiplication of two sides by each other, that is to say side EB times side CE, times the angle, times sinus the angle between those two sides, that is actually sinus 45 degrees over 2. BE equals to the square root of 10 times CE. C equals to the square root of x squared plus 9 times sinus 45 degrees over 2. So if you found out that the area of the green shape, the area of the green triangle BCE equals to BEEB, that is square root of 10 times CE, that is actually square root of x squared plus 9 times sinus the angle between the two sides, that is actually 45 degrees, so it is sinus 45 degrees over 2. So according to equation 2, the area of the green shape is actually the area of the green triangle BCE is equal to sinus square root of 10 times square root of x squared plus 9, and sinus 45 degrees is square root of 2 over 2, and we have to divide it by 2 again. So in total, if you found out that according to equation 2, the area of the green triangle BCE is equal to the square root of 2, the square root of 2 times the square root of 10, the square root of 20 times the square root of x squared plus 9 divided by 2 times 2. And again, the area of the green triangle BCE, according to the second method of calculation, equals to the square root of 20 times the square root of x squared plus 9 over 2 times 2. But according to the first method, the area of the same green triangle BCE is equal to so we calculate the area of this triangle BCE according to the first method. It is equal to the base BC times the height edge over 2. We found out that according to the first method of calculation, area of the green triangle BC equals to 1 plus x times 3 over 2. So we have two equations for the area of the green triangle BC. Therefore, we get equation 3 that says that the area of the green triangle BCE, according to the first method of calculation, must be equal to the area of triangle BCE according to the second method of calculation. And we already found out that thereafter BC according to the first method of calculation equals to 1 plus x times 3 over 2. And it must be equal to the area of the rectangle BC according to the second method of calculation. According to the second method of calculation, the area of the rectangle BC equals to the square root of 20 times x squared plus 9 over 2 times 2. So equation 3 says that the area of triangle BC according to the first method of calculation must be equal to the area of triangle BC according to the second method of calculation. And the area of triangle BC equals, according to the first method of calculation, equals to 1 plus x times 3 over 2, and it equals to the area of triangle BC according to the second method of calculation, therefore equals to the square root of 20 times x squared plus 9 over 2 times 2. So here we have 2 on both sides of this equation, so 2 will get cancelled. And after you cancel 2, in this side of question 3, we left only with 3 times 1 plus x, and it equals to, here we have square root of 20 is 5 times 4, so we substitute 20 by 5 times 4, so inside the root we have 4 times 5, that is 20, times the square root of x squared plus 9 over 2. So if you found out that according to equation 3 times 1 plus x equals to the square root of 4 is 2. So inside the brackets, inside the root, we have to be 5, so it is 2 times square root of 5, square root of x squared plus 9 over 2. So here we have 2 in the numerator, 2 in the denominator, so 2 gets cancelled. So cancel 2, in the side of the equation we have to with 3 times 1 plus x equals to the square root of 5 times the square root of x squared plus 9. And again, according to equation 3, we found out that 3 times 1 plus x equals to the square root of 5 times the square root of x squared plus 9. So here we will square both sides of this equation. Three squared is 9, and 1 plus x squared is 1 plus x squared. The square root of 5 is 5, and the square root of x squared plus 9 is x, the square root of x squared plus 9 equals to x squared plus 9. The square cancels the root, and we left only with x squared plus 9. So in total, if you found out that 9 times x, 1 plus x squared equals to 5 times x squared plus 9. So we have, in this side of the equation, we have 9 times 1 plus x squared. 1 plus x squared equals to 1 squared, that is 1, plus x squared, plus 2 times 1 times x, that is 2x, and is equals to, we'll open the bracket on the other side of the equation, this side of the equation, so 5 times x squared is 5x squared, and 5 times 9 is 45. So total according to equation 3, if we found out 9 times 1 plus x squared plus 2x equals to 5x squared plus 45. Here we open the brackets on this side of this equation 3. get that according to equation 3, 9 times 1 is 9, plus 9 times x squared is 9x squared, plus 9 times 2x is 18x, and this equals to 5x squared plus 45. And again, according to equation 3, I should found out that 9 plus 9x squared plus 18x equals to 5x squared plus 45. Here we subtract 5x squared from the equation 3. So in this side of the equation 5x squared gets cancelled. On the other side of the equation 9x squared plus 5x squared is 4x squared. You also here 18x plus 9 equals to 45. Here we subtract 45 from this equation 3. So you get that according to this equation 3, 4x squared plus 18x, we have 9 minus 45 is minus 36 equals to 0. So here we will divide this quadratic equation by 4 and finally get that according to equation 3, 4x squared over 4 is x squared plus 18x over 4 is 4.5x, minus 36 over 4 is minus 9 equals to 0 over 4 is 0. So to that we should now know that x squared plus 4.5x minus 9 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 4.5x minus 9 equals to 0, the variable that we are looking for is x. The coefficient a equals to 1, the coefficient b equals to 4.5, and the coefficient c equals to minus 9. So actually we have all the data that is needed in order to find out the variable that we are looking for, this x. We just have to put the data of our specific quadratic equation inside the general formula for x. In this way we'll find out the value of the values of x, because x might have two solutions. So we do it now and get that x equals to minus b, b equals to 4.5, and therefore minus b is minus 4.5 plus minus square root of b squared. B is 4.5, therefore b squared is 4.5 squared. This is 20.25 minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c. C is 9. Minus 4 times minus 9 is plus 36. Over 2a. A is 1, so 2a is 2 times 1, that is 2. So in total we found out that x, this is the variable that we're looking for in this question, equals to minus 4.5 plus minus. Inside the root we have 20.25 plus 36 equals to 56.25. Divided by 2. So x equals to minus 4.5 plus minus the square root of 65 point, the square root of 56 over 25 is 7.5 divided by 2. Okay, again, we should find out that x equals to minus 4.5 plus minus 7.5 over 2. So here we have two solutions that are possible for x. The first solution for x is that x is equal to minus 4.5 minus 7.5 over 2. Minus 4.5 minus 7.5 is minus 12 over 2. Minus 12 over 2 is minus 6. So according to the first solution for x equals to minus 6 units in its name. But because of the fact that x is the length of line segment AD, x as a length, it must be a positive number. 6 is a negative number, so this solution is an incorrect solution. We cancel the solution and we will take into account only the second solution for x. The second solution for x is that x is equals to minus 4.5 plus 7.5 over 2. Minus 4.5 plus 7.5 is 3 over 2. So x equals to 3 over 2, that is 1.5. X equals to 1.5 units in its name. Okay. This is the 78 equals to 1.5 units in its name. And therefore, BC in total equals to 1 plus x. X is 1.5, and therefore BC in total equals to 1 plus 1.5, that is 2.5. That is to say, the base of this grand triangle BC, the base BC is 2.5 units. And we already found out that the height is 3. Now it is very easy to find out the area of the green shape. The area of the green shape the green shape is actually the green triangle BC. So the area of this green shape is equal to the area of the green triangle BC. And the area of any triangle equals to the base of the triangle times the height over 2. The base is BC times the height edge over 2. The base BC equals to 2.5 units. The height edge equals to 3 over 2. 2.5 times 3 is 7.5 over 2. 7.5 over 2 is 3.75 units in its name. 3.75 square units in its name. And again, I should find out that the area that we are looking for this question, that is the area of this green shape, in total is equal to 3.75 square units in its size. So we finish with the first method. In the next step, I present to you how to find out the area of this green shape according to the second method. So, first of all, quadrilateral ABCD is a rectangle, and you know that all the angles inside the rectangle are right angles. So, those four angles are all right angles. In addition, we know that the opposite sides of a rectangle are equal to each other. So in rectangle ABCD, side AB must be equal to the opposite side DC, but AB is 3, therefore the opposite side DC must be also equal to 3 units in its length. We define the length of line segment ED as x, as we already done in the first method. So after ABCD, side AD must be equal to the opposite side BC, but AD in total it is 1 plus x, and therefore the opposite side BC must be also equal to 1 plus x units in its length. In the next step, we define this angle, the angle AEB, is theta. So, in the right triangle, line AEB, tangent theta equals to AB over AE. And again, in this right triangle AEB, tangent theta equals to AB over AE. So tangent theta equals to AB is 3. Over AE is 1. So in total we found out that tangent theta equals to 3 over 1, that is 3. So according to equation 1, tangent theta equals to 3. We have a trigonometric identity. It says that tangent 45 degrees plus theta. This is the first trigonometric identity. Tangent 45 degrees plus theta equals to 1 plus tangent theta over 1 minus tangent theta. Already now, this will be equation 2. So, tangents 45 degrees plus theta equals to 1 plus tangent theta over 1 minus tangent theta. We already found out that tangent theta equals to 3. So we can substitute tangent theta by 3. We'll do it now and get that in the numerator in total we have 1 plus tangent theta, that is 3. While in the denominator we have 1 minus tangent theta, that is 3. So in total we have 1 plus 3 is 4 over 1 minus 3 is minus 2. Minus 4 over minus 2 is minus 2. So total according to equation 2, we have found out the tangents close to, sides are equal to each other. Tangents 45 degrees plus theta equals to minus 2. We will focus on the right side of the straight line AD. AD is one side of rectangle, therefore it is absolutely a straight line. So we'll focus on the right side of the straight line AD. We'll focus on at the right side of the straight line AD at point E. According to rule 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of the straight line AD at point E? We have this angle that is theta, plus 45 degrees, plus this missing angle, in total must be equal to 180 degrees, according to rule 3. So, write it now. So, if we focus on the right side of the straight line AD at point E, the sum of the angles must be equal to 180 degrees according to rule 3. Which angles we have at the right side of the straight line AD at point E? We have theta plus 45 degrees plus this missing angle, the angle DEC, in total the sum of those three angles must be equal to 180 degrees according to rule 3. Read again. The sum of the angles on the right side of the straight line AD at point E must be equal to 180 degrees according to rule 3. So which angles we have at the right side of the straight line AD at point E? We have theta plus 45 degrees plus the third missing angle, that is actually angle DEC, in total must be equal to 180 degrees in their sizes. According to rule 3. So here we subtract theta plus 45 degrees from this equation. We get that the missing angle DEC is equal to 180 degrees minus theta plus 45 degrees. So if we found out that this is the missing angle DEC, this is equals to 180 degrees minus theta plus 45 degrees. In the next step, we'll focus on this right triangle EDC. On the right triangle EDC, this right triangle EDC, tangents of this angle is actually 180 degrees minus theta plus 45 degrees. So the tangents of this angle equals to DC minus ED. And again, in this side line EDC, tangents 180 degrees minus theta plus 45 degrees equals to DC over AD. DC is 3 over ED. ED is X. So if you want to know that this is equation 2. to then we found out that according to the equation 2, tangent 180 degrees minus theta plus 45 degrees equals to 3 over x. Tangent 180 degrees minus theta plus 45 degrees equals to 3 over x. We have another trigonometric identity. The second trigonometric identity that says that tangent 180 degrees minus theta equals to minus tangent theta. So according to this trigonometric identity, we get that tangent 180 degrees minus theta plus 45 degrees equals to minus tangent theta plus 45 degrees. So, let you know, tangent 180 degrees minus theta plus 45 degrees, according to the trigonometric identity that I presented to you, it is equal to minus tangent theta plus 45 degrees. This is to say, you can substitute tangent 180 degrees minus theta plus 45 degrees by minus tangent theta plus 45 degrees. We do it now and get it according to equation 2. You can get tangent 180 degrees minus theta plus 45 degrees equals to minus tangent theta plus 45 degrees. So substitute tangent 180 degrees minus theta plus 45 degrees by minus tangent theta plus 45 degrees. And it is equal to 3 over x. Again, according to equation 2, we found out that minus tangent theta plus 45 degrees is equals to 3 over x. But we only found out that tangent 45 degrees plus theta equals to minus 2. So the tangent 45 tangent theta plus 45 degrees minus 2. Okay. So, and we get that here tangent theta plus 45 degrees equals to minus 2, and we have minus also here, so we have this minus over the minus here, and it equals to 3 over x. Minus 2 is plus 2, so 2 equals to 3 over x. Here we multiply this equation 2 by x, and so we get that according to equation 2, 2 times x equals to 3. Here we divide this equation by 2, equation 2 by 2. We get that x equals to 3 over 2, that is 1.5 units in its time. So she found out that x equals to 1.5 units. So BC equals to 1 plus x. 1 plus x is 1 plus 1.5, that is 2.5. So she found out that the base triangle BC equals to 2.5. So in the next step, I'll repeat on the same process that we already done in the first method. that is to say, from point E, we will draw perpendicular on BC. Again, from point E, we will draw perpendicular on the base BC of the great triangle BCE. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We define the touching point of the perpendicular from point E inside BC. This point is point S. By doing this construction, we can do the small quadrilateral ABSC. Inside this small quadrilateral ABSC, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, so 270 degrees plus the size of this 4-piece angle in total must be equal to 360 degrees. According to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4-piece angle must be equal to 90 degrees in size. So from the moment that angle theta is definitely less than 90 degrees. Okay. So in quadrilateral ABSE, we have 4 right angles, and therefore we can relate to quadrilateral ABSE as a rectangle. As you know, this is the small quadrilateral ABSE, it is a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So, side AB equals to the opposite side ES. AB is 3, the opposite side ES must be also equal to 3 units in itself. Again, E is perpendicular on BC. So, can relate to ES, the perpendicular ES is the I to the base BC. So we define ES as H is the operation for height. And the area of the green shape equals to the area of the green tile BCE. The area of the green shape actually the area of this green tile BCE. Again, the area of the green shape is actually the area of the green triangle BC. The area of the green triangle BC equals to the base BC times the height edge over 2. And again, the area of this green triangle BCE equals to the base BC times the height edge over 2. BC is 2.5 times the height edge is 3 over 2. So don't have to know that the area of the green shape, that is the area that we are looking for with this question, is equals to 2.5 times 3 over 2. 2.5 times 3 is 7.5 over 2. 7.5 over 2 is 3.75 units in itself. So in both methods, we found out that the area of this green shape, that is the area that we are looking for this question, is equals to 3.75 units, 3.75 square units in its size. Okay, so in the next step, I will start the lecture. We start by the repetition of the solution of the first method, and then we repeat on the solution of this second method. question, I found out the area of this green shape using two different methods. So in the drawing, we have rectangle ABCD. Side AB of rectangle ABCD equals to 3 units in itself. This is line 7 AE. This equals to 1 unit in itself. This is angle BEC. This equals to 45 degrees inside. Again, our task is to find out the area of this green shape. This is actually the green triangle BEC. So we have to find out the area of this green triangle BEC. So we start with the first method. Okay, to the solution of the first method. First of all, it is given as the equation that quadrilateral ABCD is a rectangle. Therefore, all the angles inside the rectangle are right angles. So all those 4 angles are all right angles. And in the next step, we implemented the Pythagoras theorem on this right triangle ABE. Only to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle ABE, BE squared, that is the square of the hypotenuse, equals to AE squared plus AB squared. And again, in the right triangle ABE, only to the Pythagoras theorem, BE squared, that is the square of the hypotenuse, equals to AE squared plus AB squared. B is the missing hypotenuse, so we leave it as it is, and it's equals to AE squared. A is 1, therefore A squared is 1 squared, that is 1, plus AB squared. AB is 3, therefore B squared is 3 squared, that is 9. So in total, if we found out that BE squared equals to 1 plus 9, that is 10. So BE squared equals to 10. Here we took out all the equation, if we found out the missing hypotenuse BE equals to the square root of 10 units in itself. This is the missing hypotenuse BE, is equals to the square root of 10 units in itself. In the next step, we implemented the Pythagoras theorem on this right triangle EDC. In the right triangle EDC, according to the Pythagoras theorem, EC squared, that is the square of the hypotenuse, equals to ED squared plus DC squared. Okay, again, in the right triangle EDC, according to the Pythagoras theorem, EC squared, that is the square of the hypotenuse, equals to ED squared plus DC squared. EC is the missing side, so the missing hypotenuse, so we leave it as it is. So this EC squared equals to ED squared. ED is x, therefore ED squared is x squared, plus DC squared. DC is 3, therefore DC squared is 3 squared, that is 9. So in total, we found out that EC squared equals to ED squared, EC squared equals to x squared plus 9. Here we took out all this equation, if I found out that the missing hypotenuse EC equals to the square root of x squared plus 9. This is the missing hypotenuse EC. With this right triangle EDC, this equals to the square root of x squared plus 9 units in its name. In the next step, we did the construction. This is say from point E, we go perpendicular on BC. Again, from point E, we go perpendicular on side BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point E and BC. This point is point S. Okay, by doing this construction, we created the small quadrilateral ABSC. Inside the small quadrilateral ABSC, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, total must be equal to 360 degrees according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So in quadrilateral ABSC we have 4 angles, therefore we can relate to this quadrilateral ABSE is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABSE, side AB must be equal to the opposite side SE. But AB is 3, therefore the opposite side SE is also 3. We define ES as edge. ES is the height to the base BC, so we define it as edge. ES equals to edge according to our definition, and it equals to 3. According to the rule, the opposite sides of a rectangle are equal to each other. So edge equals to 3, the height to the base BC equals to 3 units in its length. So our task is to find out the area of this green shape. What is the green shape? The green shape it is the green right triangle BCE. So we have to find out the area of this green right triangle BCE. What is the area of any triangle? The area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of this green triangle BC equals to the base BC times the height AC, this is edge over 2. And again, the area of this triangle BC according to the first method of calculation equals to the base BC times the height edge over 2. And we have actually we define the side ED as x and the AD in total equals to 1 plus x. In left triangle ABCD, the opposite sides are equal to each other. That is to say, side AB equals to the opposite side BC. But AD in total is 1 plus x, and the opposite side BC must be also equal to 1 plus x units in itself. Likewise, AB equals to DC, AB equals to 3, and therefore the opposite side DC must be also equal to 3 units in itself. So the base BC equals to 1 plus x units in itself. So substitute the base BC by 1 plus x times the height edge, as edge is 3. So substitute edge by 3. So in total we shall know that the area of this green right triangle BC, this is the area of the green shape, equals to 1 plus x times 3 over 2. This is according to the first method of calculation. But we can find out the area of this main triangle BCE according to second method of calculation. Actually, we know that this is triangle ABC. In triangle ABC, side AB equals to A units in its length, side AC equals to B units in its length. This is angle BAC, this is theta. The area of this triangle ABC, that could be any triangle, equals to the multiplication of two sides by each other. That is to say, A times B times sinus the angle between those two sides, that is theta over 2. So the area of this triangle ABC equals to A times B times sinus theta over 2. Use this new formula in order to find out the area of this triangle BEC, triangle BCE. The area of this triangle BCE, according to the formula that I presented to you, must be equal to the base to the side EC times side EB times sinus 45 degrees over 2. So again, the area of this triangle BC equals to the multiplication of those two sides by each other times sinus 45 degrees over 2. So according to the second method of calculation, the area of the triangle BC equals to the multiplication of those two sides by each other times sinus the angle between those two sides, that is 45 degrees over 2. So it is EC times EB times sinus 45 degrees over 2. EB equals to square root of 10, EC equals to the square root of x squared plus 9 times sinus 45 degrees over 2. So again, EB equals to the square root of 10, C equals to the square root of x squared plus 9 times sinus 45 degrees over 2. So here we have the after ABC equals to the square root of 10 times the square root of x squared plus 9 times sinus 45 degrees over 2. Sinus 45 degrees is square root of 2 over 2, and the way to divide it by 2. So in total, the area of the triangle BCE, according to the second method of calculation, equals to the square root of 10 times the square root of x squared plus 9 times square root of 2 over 2 times 2. The square root of 10 times the square root of 2 equals to the square root of 20. So in total, the area of the green triangle BC, according to the second method of calculation, equals to the square root of 20 times the square root of x squared plus 9 over 2 times 2. This is according to the second method of calculation. But according to the first method of calculation, the area of triangle BC equals to the base of the triangle times the height of the base over 2. the base is 1 plus x, the height of the base edge is 3 over 2. So according to the first method of calculation, the area of the third triangle BC equals to 1 plus x times 3 over 2. In the next step, we created the equation 3 that said that the area of triangle BC according to the first method of calculation must be equal to the area of the same triangle BC according to the second method of calculation. The area of triangle BC according to the first method of calculation equals to 1 plus x times 3 over 2, and it must be equal to the area of triangle BC according to the second method of calculation. This is actually the square root of 20 times the square root of x squared plus 9 over 2 times 2. Here we have 2 on both sides of this equation, so 2 will get cancelled. After you cancel 2, this side of the equation we left only if 3 times 1 plus x, while on the other side of the equation we left with we substitute 20 by 5 times 4 or 4 times 5, and we have here again 20 is 4 times 5, so it is the square root of 4 times 5 times the square root of x squared plus 9 over 2. So 3 times 1 plus x equals to the square root of 4 is 2, so we took 4 out of the root. So the square root of 4 is 2, so inside the root we left only the square root of 5 times the square root of x squared plus 9 over 2. We have 2 in the denominator, so 2 will get cancelled. After you cancel 2, this is the equation we have 3 times 1 plus x, while on the other side of the equation we left only with square root of 5 times square root of x squared plus 9. Here we squared both sides of this equation 3. So here 3 times 1 plus x squared equals to 3 squared, that is 9, times 1 plus x squared, and square those this side also the equation. The square root of 1 squared is 5, and we have the square root of x squared plus 9 squared equals to x squared plus 9, because of the fact that the square cancels the root, and we left only with x squared plus 9. So in total, according to equation 3, we should find out that 9 times 1 plus x squared equals to 5 times x squared plus 9. We open the brackets on both sides of this equation 3. So in this end of the equation, we have 9 plus 1 plus x squared. 9 plus 1 is x squared equals to 1 squared, that is 9, plus x squared, plus 2 times 1 times x, that is 2x, and it is equals to 5 times x squared plus 9. 5 times x squared is 5x squared, and 5 times 9 is 45. We open the brackets on this equation 3 on this side of the equation. 9 times 1 is 9, 9 times x squared is 9x squared, and 9 times 2x is 18x, equals to 5x squared plus 45. Repeat again. After we open the brackets on this side of the equation, we should find out that (9 plus 9x squared plus 18x equals to 5x squared plus 45. Here we subtract 5x squared from this equation, so here 5x squared will get cancelled. Here we have 9x squared minus 5x squared is 4x squared, and we are left here with 18x plus 9 equals to 45. Here we subtract 45 degrees from 45 from this equation 3. I have found out that 4x squared plus 18x, and 9 minus 45 is minus 36 equals to 0. Here we divided this equation 3 by 4, and found out that 4x squared over 4 is x squared, 18x over 4 is 4.5x, minus 36 over 4 is minus 9 equals to 0 over 4 is 0. So to that we found out that x squared plus 4.5x minus 9 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the formula. X equals to minus b plus minus square root of b squared minus 4 times a times c. In our specific quadratic equation, that is to say x squared plus 4.5x minus 9 equals to 0, the variable that we are looking for is x. And the coefficient a of this equation is 1, the coefficient b is 4.5, and the coefficient c is 9. So the only thing that is left to do is to put the data of our specific quadratic equation is data inside the general formula for x. In this way, we found out the values of x. We did it and we found out that x equals to minus b. B is 4.5, therefore minus b is minus 4.5, plus minus square root of b squared. B is 4.5, therefore b squared is 4.5 squared, is 20.25, minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c. C is minus 9, so minus 4 minus 9 is plus 36. So in total inside the root, we have 20.25 plus 36 over 2a. A is 1, so 2 times a is 2 times 1, that is 2. So x equals to minus 4.5 plus minus 20.25 plus 36 is 56.25. So inside the root, we have to make 56.25 over 2. The square root of 56.25 is 7.5. So in total, we found out that x equals to minus 4.5 plus minus 7.5 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 4.5 minus 7.5 over 2. Minus 4.5 minus 7.5 is minus 12, and minus 12 over 2 is minus 6. So we shall find out that the first solution for x is that x equals to minus 6 units, minus 6 units in its length. X is the length of 170d, so x is a length, it must be a positive number, therefore x can never be equal to 1/6. So we cancel the first solution for x and we took into account only the second solution for x. The second solution for x is as follows: x equals to minus 4.5 plus 7.5 over 2. Minus 4.5 plus 7.5 is 3, so it is 3 over 2. 3 over 2 is 1.5. So according to the second solution for x is x equals to 1.5 units in its length. Our task is to find out the area of this green shape that is actually the green triangle ABC. Again, the green shape is actually the green triangle BCE. The area of this green triangle ABC equals to the base BC times the height edge over 2. Again, the area of the green triangle BC equals to the base BC times the height edge over 2. BC, the base BC is 1 plus x is 1.5, 1 plus 1.5 is 2.5. So the base BC is 2.5, the height edge is 3 over 2. So today we found out that the area of the green shape, according to the first method, equals to 2.5 times 3 over 2. 2.5 times 3 is 7.5 over 2. 7.5 over 2 is 3.75 square units in size. We should find out that the area of this green shape, that is the area that we are looking for this question, is equal to 3.75 square units in size. So, next step, I put on the solution according to the second method for this question. So, quadrilateral ABCD is rectangle, therefore all those four angles inside rectangle ABCD must be called right angles. In addition, we know that the opposite sides of a rectangle are equal to each other. So, in rectangle ABCD, side AB must be equal to the opposite side DC, but AB is 3, therefore the opposite side DC must be also equal to 3 units in its length. We define the length of side 97ED as x, therefore AD in total equals to 1 plus x. So in rectangle ABCD, side AD must be equal to the opposite side BC, but AED is 1 plus x, and therefore the opposite side BC must be also equal to 1 plus x units in its length. In the next step, we did a construction, that is to say, from point E we do perpendicular on BC. Again, from point E we do perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point E and BC. This point is point S. By doing this construction, we can do the small quadrilateral ABSC. Inside this small quadrilateral ABSC, side AE must be equal to the opposite side SB. But the most important thing is that side AB equals to the opposite side ES. AB is 3, therefore the opposite side ES must be also equal to 3 units in itself. ES is perpendicular to the base BC, and therefore we define the perpendicular ES edge as edge. It is abbreviation for height. So edge equals to 3 units in itself. In the next step, we define this angle AEB as theta. So in the right angle AEB, tangent theta equals to AB over A. Again, in the right angle ABE, tangent theta equals to AB over A. AB is 3, AE is 1, so in total tangent theta equals to 3 over 1, that is 3. So according to equation 1, tangent theta equals to 3. Here we have the trigonometric identity that says that tangent 45 degrees plus theta equals to 1 plus tangent theta over 1 minus tangent theta. So it is 1 plus tangent theta, but we found out that tangent theta equals to 3. So we substitute tangent theta by 3, so it is 1 plus tangent theta is 1 plus 3 over 1 minus tangent theta. So it is 1 minus tangent theta, that is 3, so it is 1 minus 3. 1 plus 3 is 4 over 1 minus 3 is minus 2, so minus 4 over minus 2 is minus 2. So if you found out that according to equation 2, tangent 45 degrees plus theta equals to minus 2. But according to equation 1, tangent theta equals to 3. In the next step, we focus on this AD is one side of rectangle ABCD. So AD is the side of a rectangle, it is absolutely a straight line. So if we focus on the right side of the straight line AD at point D, here the sum of the angles must be equal to 180 degrees according to Rule 3. Rule 3 said that the sum of the angles from one side of the straight line is equal to 180 degrees. So which angles we have in the right side of the straight line AD at point E? We have this angle that is theta, plus this angle that is 45 degrees, plus this angle that is actually angle DEC. In total, the sum of those three angles must be equal to 180 degrees according to Rule 3. So in the right side of the straight line AD at point D, according to Rule 3, the sum of the angles must be equal to 180 degrees. So which angles we have at the right side of the straight line AD at point D? We have theta plus 45 degrees, plus the missing angle DEC. In total must be equal to 180 degrees according to Rule 3. So here we subtract theta plus 45 degrees from this equation, and we found out that the missing angle DEC equals to 180 degrees minus theta plus 45 degrees. This is the missing angle DEC. Equals to 180 degrees minus theta plus 45 degrees. In the next step, we focus on this right triangle ADC. In this right triangle ADC, tangent 180 degrees minus theta plus 45 degrees is equals to DC over AD. Again, tangent 45 degrees minus theta plus 45 tangent 180 degrees minus theta plus 45 degrees equals to DC over AD. And again, in the right triangle ADC, tangent 180 degrees minus theta plus 45 degrees equals to DC over AD. DC is 3, ED is X. DC is 3, ED is X, so in total, tangent 180 degrees minus theta plus 45 degrees equals to 3 minus X. Here we have the trigonometric identity that says that tangent 180 degrees minus actually we have the trigonometric identity that says that tangent 180 degrees minus theta equals to tangent we have the trigonometric identity that said that tangents under the degrees minus theta equals to minus tangents theta. So according to this trigonometric identity, we get that tangents under the degrees minus theta plus 45 degrees equals to minus tangents theta plus 45 degrees. Okay? And according to equation 2, we have here tangents under the degrees minus theta plus 45 degrees. And according to the trigonometric identity that I presented to, tangents under the degrees minus theta plus 45 degrees equals to minus theta plus 40, minus tangents theta minus tangents theta plus 45 degrees. So substitute this expression by this expression because they are equal to each other according to the trigonometric identity that I presented to. So substitute those two expressions by each other. So tangents tangents under the degrees minus theta plus 45 degrees equals to minus tangents theta plus 45 degrees. So according to equation 2, tangents under the degrees minus theta plus tangents under the degrees minus theta plus 45 degrees equals to minus tangents times theta plus 45 degrees. And therefore we substitute tangents under the degrees minus theta plus 45 degrees minus tangents theta plus 45 degrees. Okay, those two expressions are equal to each other according to the trigonometric identity that I presented to you. Tangents under the degrees minus theta equals to minus tangents theta. So this is equals to minus tangents theta plus 45 degrees. And according to equation 2, it is equal to 3 over x. But we already found out that tangents 45 degrees plus theta equals to minus 2. So substitute tangents theta plus 45 degrees by minus 2. This is 2 according to the equation that I presented to you. We substitute tangents theta plus 45 degrees by minus 2. We have here minus 2 according this minus here, and it equals to 3 over x. So in total we found out that minus 2 equals to 3 over x. Minus 2 is plus 2, so 2 equals to 3 over x. Here we multiply this equation by 2 and we found out that 2x equals to 3. Here we divided this equation by 2 and we found out that x equals to 1.5 units in its length. ED is equals to x equals to 1.5 units in its length. And therefore the base BC of the rectangle BC equals to 1 plus x. X is 1.5, therefore 1 plus x is 1 plus 1.5, that is 2.5. So the base BC of the rectangle BC equals to 1.25 units in its length. The height AC equals to h, and h equals to 3. So in total, if you get the area of the green shape, the area of this green shape equals to the area of this green triangle EBC. Again, the area of the green shape equals to the area of the green triangle BC. It is identical to the area of the green triangle BC. The area of this green triangle BCE equals to the base BC times the height edge over 2. Again, the area of the green triangle BC equals to the base BC times the height edge over 2. The base BC is 2.5 and the height edge is 3. Okay, the base BC is 2.5 units and the height edge is 3 over 2. 2.5 times 3 is 7.5 and 7.5 over 2 is 3.75 square units in its size. So in both methods, we found out that the area that we are looking for this question is equal to 3.75 square units in its size. Okay, thank you very much.